for the Unit 8 group quiz, okay? This is going to be very, very, very similar to what your actual test is going to look like on Monday, okay? If we're going to graph, the first thing you need to do is make an XY table, okay? You want to plug in 2, 1, 0, -1, and -2, okay? Even though we already know the kind of rough sketch of this, I still want you to use exact values on this. So if you plug in, 5 squared would give you 25. 5 to the first gives you 5. 5 to the 0 is 1. 5 to the -1 is 1/5. 5 to the -2 is 1 over 25. So if you plot those points, we go over 2, up 25, so that's like way, way, way up here. Over 1, up 5. I think it's right there. Over 0, up 1, and then these are just really, really close, really, really close. When you draw this, do not cross the x-axis. Okay, you can get it really close, but do not cross the x-axis because then it will mark it wrong on your test. Same type of thing with y equals 1/3 to the x. Again, we're going to make an xy table. Plug in 2, 1, 0, -1, and -2. So 1/3 squared gives you 1/9. 1/3 to the first gives you 1/3. 1/3 to the 0 is 1. -1 gives you 3. -2 is +9. So if you graph those, we start over 2 at 1/9. So it's really close, over up 1. -1 up 3. And -2 up really high up here. This is an inverse graph. Okay, so it's never going to actually touch, but these are like exactly inverse of one another. Okay, but I do want exact points on the graphs. On number 3, given the equation y equals x to the n, where 0 is less than x is less than 1 and n is greater than 0, which statement is true? So we need to pick a value. Okay, if x is in between 0 and 1, I'm just going to pick a fraction, so say 1/2. N is greater than 0. So if n is 2, for instance, if you set this up so you have 1/2 squared, that gives you a value of 1/4. And that fits in between 0 and 1. That is the only one that makes sense. So your answer would have been C. Should be C. Number 4, if the equation of y equals 7 to the x is graphed, which of the following values would produce a point closest to the x-axis? Whole numbers raised to the x exponent are increasing, so that means it's going to go up, up, up. So the more negative, the better. Okay, so the more negative tells you that it will be the closest to the x-axis. So this would be B. For number 5, very similar, but if it's a fraction raised to the x, that is a decreasing graph. Okay, again, we'll always touch at 0, 1. This one will be closest as you get the most positive. Okay, 5 over 2 is actually 2.5, so that is the most positive. So that would produce a point closest to the x-axis. It's never actually going to touch, but it's going to get really, really, really close. Number 6, if a certain element decays over time with a half-life of 1,600 years, use the formula to determine how many grams will remain after 3,200 years if 300 grams were present originally. So y equals 300 grams originally present times 1/2 to the t is 3,200 over half-life of 1,600. So 300 times 1/2 squared, that gives you 300 times 1/4, and 1/4 of 300 is 75. And remember, this does matter that we put grams. Okay, 75 grams. Make sure you're not multiplying the 300 and the 1/2 first before you take the square of it. That would definitely be wrong. Number 7, solve for x. This is the stuff that we just did. Okay, solve for x. If we do that, you need to take this to the reciprocal power, so to the 3/5 power. These go away. These reduce each other away. So we get x by itself equals, if I rewrite this in power handle, 32 cubed and the 5th root of 32. If you know your powers, then you should know that the 5th root of 32 is 2, and 2 cubed, 2 times 2 times 2, is 8. Not 2 times 3, but 2 cubed gives you 8. For number 8, if you want to write an equation, okay, before you start looking at these, the way that we write an equation, and this is kind of new, we haven't really done much of this, is you always write y equals the amount you start with, so the amount you start with is 400, multiplied by what happens each time. This one is multiplying by 2, and then just write to the x. So the number equals the initial amount times its multiplier to the x. That matches with D. Okay, but that's how we write these. You haven't had to write them yet. You've just had to match them up, but that is actually how you write them. Okay, for number 9, divide both sides by 2. Divide by 2, we get x to the 1/2 equals 3. Take those to the reciprocal power, so reciprocal power is to the second power. These will cancel each other out, so x equals positive 9. For number 10, we need to get the same base. So get the same base and drop the x, or excuse me, and then drop the base. So 9 is 3 squared raised to the 2x equals 3 cubed raised to the x minus 1. If you distribute those, we get 3 to the 4x equals 3 to the 3x minus 3. Make sure you multiply that all the way through, not just the x. Then you can drop the bases and set the exponents equal to one another. We subtract 3x, x equals negative 3. Okay, next one, on number 11. Again, we want to get these to the same power, so base of 5, x minus 2 equals 125 is 5 cubed multiplied by 5 to the 1/2. These are next to each other, they add together. Okay, so if you add those together, we get 5 and 3.5, but that's just not a very nice way to write that. Okay, so if we do that, we're going to drop these. Okay, if you set them equal to, you're going to get x minus 2 equals 3.5. It's a little bit easier to write this way. Okay, and we will change that. So if you change this, if you add to both sides, you get x equals, add the 2, 5.5. That I want written as an improper fraction, so take the big number, multiply by the bottom, add the top. So that would give you 11 over 2. For number 12, okay, solve for x. Again, I'm going to get these to be the same base, so this is 3 to the negative 1 multiplied by x minus 5 equals 3 to the 4 minus 2x. If you distribute through, we get 3 to the negative x plus 5 equals 3 to the 4 minus 2x. Drop your bases, they reduce each other away. We got negative x plus 5 equals 4 minus 2x. On this kind of thing, I specifically asked the calculus and AMA teachers, they do not want you to ever leave it as a fraction in the base. We always want to have whole numbers, not fractions in the base. So that's why you need to change it to be base 3, not change the one on the right to be a base of 1/3. Okay, they specifically asked to please not do that. Okay, for this one, add 2x to both sides. It's going to leave us with x. Subtract 5 from both sides. And that gives us x equals negative 1. Okay, so 11, negative 1. And the last page for this, number 13, it says, again, solve for x. Okay, if we're going to solve for x, first thing you want to do is get rid of the 3. So x plus 2 raised to the 2/3 power equals 25. Raise both sides to the reciprocal power, so 3 over 2. These reduce each other away. We got x plus 2 equals, if you rewrite this in power handle, it's 25 cubed square root. Right? X plus 2 equals, square root of 25 is 5 cubed, so x plus 2 equals 125. Subtract 2, x is 123 for an answer. Okay, number 14, again, solve for x. You need to get these to be the same base. The only base that will work here is a base of 2. So 2 cubed raised to the 2x minus 8 equals 2 to the 5th power raised to the 4x. So that's 2 to the 6x minus 8, or excuse me, minus 24 equals 2 to the 20x. Drop your bases. leaves us with 6x minus 24 equals 20x. If you subtract 6x from both sides, leaves us with negative 24 equals 14x. Divide both sides by 14. And if you reduce, we should get x equals negative 12 over 7. So just reduce. Number 15. Same thing. I want to get both the same base, and I want them to be whole number bases, not fractions. So we're going to change this to 2 to the negative 1 raised to the 5 minus x equals 2 to the negative 2 raised to the x minus 2. You distribute through, 2 to the negative 5 plus x equals 2 to the negative 2x plus 4. Drop your bases. Negative 5 plus x equals negative 2x plus 4. Add 2x to both sides, so 3x equals, add 5 to both sides, 9, so x equals 3. Okay, this is probably, number 16 is the only one that you would actually need a calculator for. Everything else you should be able to do on your own. Okay, A is the initial amount, so you start with 50 times 2 to the T tells you time elapsed, so how many periods have elapsed, okay? So you're thinking of how many 6-hour periods are there in 3 days? There's 24 hours in each day, so there'd be 4 6-hour periods each day. Times 3 days is 12. Okay, so y equals 50 times 2 to the 12. So that's going to be 50 multiplied by 4,096. You multiply those together, we get 204,800 bacteria. Okay, and then the last one, divide both sides by 3. X to the 3 halves equals 8. Raise the reciprocal power, so raise to the 2/3 power. These will reduce each other away. So x equals, if you rewrite this in power handle, 8 squared cube root. Cube root of 8 is 2, and 2 squared equals 4. Okay, that's it. If you are understanding everything, you should be really good on this test. Okay, just make sure that you have all the rules kept straight, and you should be good. Okay, you do not have to have a calculator for your test. If you want to use one, that's fine, but you do not have to have one, and phones do not count. No phones.